Welcome folks, this is section 3.2. The first half of this is going to be solving by substituting. And substitution is best when we have one line, one equation in something like slope-intercept form and the other one in standard form. Because here I know y is, or y equals, y is the same as 2x minus 6. That means wherever I see y, I can substitute it with I said that wrong. I can substitute it with, let me read this correctly right here. I can substitute it with negative 2 times x plus 6. That's what y equals. I don't know. I need some lunch. So let's plug that in, or substitute that in for y in the top equation. So I'm rewriting this top equation because that's what I'm substituting into. So negative x plus 7 times whatever y is. Now 7 is getting multiplied with y, and y is all of this. So you need to put parentheses around what y is equivalent to, and you should do that when you substitute anyway. But now it helps us remember to take 7 times all of that. 7 times the negative 2x and 7 times the 6. So we get negative x plus, when we distribute now, we get negative 14x plus 42 equals negative 18. Make sure you combine like terms. That's a negative 15x plus 42 equals negative 18. Now once we've simplified by distributing or combining like terms, now we start solving. So we subtract 42. You get negative 15x equals negative 60. And then divide by, careful here, divide by negative 15 to undo multiplying by negative 15. So you get x equals 4. I'm going to circle that, but that's not my final answer. I need the coordinate pair, the x and y combo that works for both equations. Right now I just know that x is half of that coordinate pair. Now you can use either equation to substitute into to find y, but if we go back and use the other equation, the one that's in slope-intercept form, check this out. I just need to take negative 2 times whatever x is and add 6, and I know that x is 4. So to get y, let's do a different color. To get y, I'm going to take negative 2 times 4 and add 6. So when you do that, you get negative 2, I believe. So x is 4, y is negative 2. You could substitute that back into this other equation. I'm going to even do that real quick. Substitute in 4 for x and negative 2 for y. Punch that in your calculator and hope that you get negative 18. And you do. So it's a solution to both equations, so therefore it's a solution to the system. Same idea. I'm going to take this, whatever y is equivalent to, and put it in place of the y right there in the other equation. So I get negative 5 times x minus 5 times y. And y is, in parentheses, negative 6x minus 9. And then keep finishing up this top equation, equals negative 5. So we distribute, but be careful what number you're distributing in here. You're distributing in a negative 5. Chop slasher, that minus sign affects this 5. So we get negative 5 times negative 6, which is 30x. And then we get negative 5 times negative 9, which is positive 54. Bring the rest down. And from here, try to combine like terms to make the left side easier if you can. You get 25x. Why do I not feel good about something here? I think we're supposed to get a whole number, but I don't know. I feel like it's not going to work out. Oh, that's because this is supposed to be 45. Definitely do need lunch. That's a 45. Positive 45, so we subtract 45. So you get 25x equals negative 50. So then x equals negative 2. Once you know what x is, substitute that back into one of the equations to solve for y. But really, if we do it in the bottom equation, y is going to equal whatever negative 6 times negative 2 minus 9 is. So we get 12 minus 9, that equals 3. So y equals 3. Write it as a cute coordinate pair Aw, they're so cute together. Get it? It's funny because it's a coordinate pair and they have to be together. All right. Same idea here. This negative 5x goes in place of any y. So negative 2x minus 4 times negative 5x equals 18. Distribute, but we're really just multiplying negative 4 times negative 5, which is positive 20x. So you get 18x equals 18. Therefore, x equals 1. Go back and find y, though. So y equals negative 5 times 1. So y is negative 5. So put them together. X comma y. Oh, they're so cute together. Okay, I'm going to stop doing that. That was the second time ever in my life I've done it. But you heard both of them. Lucky you. Anywhere I see a y, I can replace it with 4x plus 8. So we get negative 12x plus 3 times, in parentheses, 4x plus 8 equals 24. Sorry for the spacing there, I got a little excited. 3 times 4x, 3 times 8 gives you 12x plus 24. Drop down the negative 12x, drop down the 24. Uh-oh, when you combine like terms, you get 0x. So we get 24 equals 24. When the x's cancel out, folks, if you end with a true statement, what you do, the solution is all real numbers. Any number in the entire universe would make the left side equal the right side in both of these equations. If you got a number that was not equal, say you got 24 equals 50, that's not true, that's false, then your solution is no solution. Ooh, I should have boxed the whole thing off. My answer, folks, is all real numbers. Not true. When I analyzed this, I thought in my thought bubble, that's true. So then I think, oh, because it's true, the answer is every single number that exists. Try some elimination here. For elimination, you're looking for a combination of either x's or y's that are opposites. So when you add the equations together, you get opposites and they cancel out that letter. So here I see opposite y's. I see a positive 8y, and the exact opposite of positive 8y is negative 8y. It has to be the exact opposite, because now I'm going to add vertically, combine like terms. I get negative 6x plus 9x is 3x, but when I combine these, I get 8y and negative 8y is 0y. I'm not going to even write that down. They're gone. And on the right side of the equal sign, I get negative 18. So now we can figure out what x is. By dividing by 3, we know that x equals negative 6. Awesome. Now we're not quite done, because once we know what x is, again, we have to go back and find y. You can use either equation, whatever looks easier for you to work with. They're both similar to me here. I see one positive or one negative number in this one. I see a couple in this one. The numbers are both about the same size. So I'm just going to do the top one. So I'm going to rewrite it, but instead of putting in x, I'm going to substitute in 6 in place of x. Or negative 6, excuse me, because x is negative 6. So that's 36. So now solve for y. Subtract 36 and then divide by 8. So y equals negative 3. Put them together, but I won't make the joke. There we are. Next one. So now I don't see opposites. Shoot. Well, because the perfect opposite of negative 12x, which is what I need the exact opposite of negative 12x, is positive 12x. Now you can multiply equations by things. And I know that if I multiply the top equation by 3, I would get a positive 12x. So I'm going to do that. So when I distribute 3 to everything, including the negative 8 over there, this new equivalent equation is 12x plus 9y equals negative 24. If you graph this green line right here, folks, or this equation, if you put that in Desmos and graph it, and you graph this one, it's the exact same line, it's the exact same equation. The numbers are just amplified up. I'm going to rewrite the bottom equation, because now when I rewrite this system, I have opposites. So now I add the equations together. I'm combining like terms. On the left, these x's cancel out, and I get 5y. On the right, I get negative 40. So that means that y is negative 8. Well, once you find out what y is, plug it back in to find x. I'm going to use the top equation because the numbers are smaller and more positive, and I just do better with that personally. But you could use the other equation and it would get you the same thing if you did your math right. So I'm going to add 20, 40 each side. So I get 4x equals 16. That means x equals 4. So put them together. There's your solution to the system. Here, let's see, the opposite of 9x is positive 9x. So I'm going to multiply the top by negative 3. Distribute that to everything. So I get positive 9x, positive 6y, negative 18. Rewrite the bottom equation because that already has a set of opposites right there. And now, add vertically, combine like terms. And sure enough, my x's cancel out. What do I get for the y's then? Oh my goodness, the y's cancel out. Now typically when things cancel out, I don't bring anything down. But check it out. We're already the equal sign. I need something written on my left side. But there's nothing there. So what number is nothing? 0. On the right side, when I add, I get negative 18 plus 18, which is also 0. So here I get another truthful statement, folks. And when our x's cancel out, it either means no solution or infinite solutions. Because it's a true statement, you get infinite solutions or all real numbers. Last one. I'm going to multiply the top one by negative 3 and the bottom one by 2. I'm going to do this quietly so Mr. Schmidt doesn't disrupt us anymore. I'll just let him do the talking. I feel like I'm going to screw up now. I have like 7 math teachers behind me.
He has 2 math teachers behind him. He's exaggerating.
Like, you can only count.
Something feels bad or wrong. All right, so let's go.
It's your shoulders. They're tight.
Like
Ha! So there our x's cancel out. We get 0x. We're not going to write it down. Here we get 41y.
That's fine.
Gosh,
We're
41.
going to get 0 on the other side.
Oh my goodness, 0.
Woohoo!
And 0
Yippee!
divided by 41.
Is?
Yippee, yippee, yippee!
Woo!
0. It's
Woohoo!
a number. It works. Are we done? No. We got to find what, folks?
Oh, what's the point?
What's the point? We got the y. We need the?
X.
Yeah, for that point. Let's use one of the equations. I'm going to use the bottom one. Is that okay, everyone?
Yeah, it doesn't have any negatives. I like that.
Could I use the top one?
Sure.
Who wants
wow.
that?
Look at the freedom here. So I'm going to rewrite the bottom equation. I'm going to substitute in 0 for y. And then simplify and solve. So 7 times 0 is actually, wow, 0.
Yeah, it is.
So I'm going to write it down. I really could have just skipped that. I'm not going to even subtract 0 off because that doesn't change anything. So really I have 3x equals 6. I should have just not written it down. That was silly. Divide by 3 to get x. X equals 2.
What's the point?
What's the point? Let's put them together. Let's put them together. Isn't that a cute pair? Look at them together. They look so nice.
Oh, there's the point.
Awesome.
There's the point.
Good job, Mr. P.
Thanks for the help, everybody. That was Miss Scott and Mr. Schmidt. If we were to graph these 2 lines, folks, that is the point where they intersect. That is the solution to the system of equations. Wow, that was a lot of fun. Mr. Schmidt, I like your sweater, by the way.
Woohoo!